All right, welcome back for another deep dive. Today we're tackling use callback in React. We're pulling straight from the official docs, and while that might sound dry, I promise it's way more interesting than you think.
Oh, yeah, definitely.
Okay, let's unpack this. Imagine you're building this super complex web app, right? Lots of interactive parts, the whole shebang, but it starts to feel sluggish. Why? Because re-rendering the entire page every time something changes, that's a performance killer. Enter use callback. It's like a memory trick for your code, so it doesn't have to keep recalculating everything from scratch.
It's all about efficiency. Use callback lets you cache or store a function's definition. That way, when React wants to re-render, it can skip the unnecessary work if the function hasn't changed.
So instead of searching for your car in a giant parking lot every time you need it, you just remember where you parked right.
Exactly. But here's where it gets really cool. Let's look at a real-world scenario. Imagine you have a component that displays a list of products. Each product has a Buy Now button. Without use callback every time the list re-renders, even if it's just to update a single product's price. A new instance of the Buy Now function would be created for each product.
So even though the logic for buying a product is the same, React is creating a brand new function for every single button. It seems like a lot of overhead, especially if you have a long list.
That's right, and this is where use callback shines. By caching the Buy Now function, we ensure that the same function instance is used for all buttons. As long as the underlying logic hasn't changed, this can dramatically improve performance, especially if the function is complex or if the list is very long.
That makes sense. It's like instead of baking a new cake every time someone wants a slice, we bake one giant cake and just cut pieces as needed. We're reusing the same core recipe, which is much more efficient.
That's a great way to put it. Now, the syntax for use callback is pretty straightforward. It's use callback, fn, dependencies. The fn is the function you want to cache. And the dependencies part, well, that's where things get interesting.
The dependencies are like a list of ingredients for our cached function. Right. If
Yeah.
any of those ingredients change, we need to make a fresh batch, so to speak.
Precisely. And these ingredients are the reactive values the function relies on. Think specific things, like a product's price in our previous example. If the price changes, we definitely need a new function. But if it's just the product's description that updates, our cast by now function is still good to go.
So use callback prevents unnecessary re-renders,
Yeah.
especially with components wrapped in memo, which, from what I understand, are designed to skip re-rendering if their props haven't changed.
Exactly. I once had to optimize a complex data visualization dashboard. Every time the user interacted with a filter, the entire dashboard re-rendered. Even if only a small portion of the data had actually changed, it was a nightmare. But by strategically using use callback for the data processing functions, I was able to isolate the re-renders to only the components that actually needed to update. The performance gains were incredible.
Wow. That sounds like a real aha moment.
Yeah.
You went from a sluggish dashboard to a lightning-fast one just by applying this one concept.
It was a game changer for sure. Now this brings us to a common question. How does use callback differ from use memo? They both sound like they're in the business of remembering things, but how are they distinct?
Yeah, I was wondering about that too. They both deal with optimization and caching, but how do they go about it differently?
Well, use callback caches the function itself, whereas use memo caches the result of a function call. Think of it this way. Use callback is like having a skilled chef who can whip up a dish perfectly every time, while use memo is like having the dish already prepared and ready to serve.
So if we continue with the cooking analogy, use memo is like having pre-chopped veggies, and use callback is knowing the recipe by heart. Both save time, but in different ways.
Exactly. Both of these tools are invaluable in optimizing React applications, but it's essential to understand when to use which one. Now, before we dive deeper into that, let's address a common misconception, that you should be using use callback everywhere.
Like some sort of magical performance dust.
Not quite. It's important to remember that use callback is a performance optimization tool, not a necessity. In many cases, your code will work perfectly fine without it. In fact, overusing it can make your code harder to read and understand.
So it's not about using it everywhere,
Yeah.
but rather knowing when and where it will have the most impact.
Absolutely. And that's where understanding the underlying principles of caching and optimization becomes crucial. We need to identify the specific areas where memoization will truly make a difference.
I'm already starting to see how these ideas can apply beyond just coding too. So it's like organizing your life to be more efficient. If you have a system for where you put your keys, you don't waste time searching for them every time you need to leave the house.
That's a great observation. These principles are all around us. Now let's shift our focus back to use callback end. Talk about some common troubleshooting issues you might encounter. One of the most common issues developers face is incorrect dependency arrays. If you're missing a dependency that your cached function relies on, you might end up with stale data and unexpected behavior.
Okay, so let's say I'm building a shopping cart component and I'm using useCallback to handle adding items to the cart. What kind of dependencies would I need to consider?
Well, you definitely need to include anything that affects the logic of adding an item to the cart. This could include the current contents of the cart, the product being added, any user-specific data like discounts or shipping preferences, and even external factors like inventory levels if you're pulling those in real time.
So if I forgot to include something like a user's discount code in the dependency array, the cached function might not reflect the actual discount when adding the item to the cart.
Exactly, and that could lead to some frustrating bugs. Debugging dependency arrays can be tricky, but there are some tools and techniques that can help. React Developer Tools, for example, lets you inspect the dependency arrays of your use callback hooks and can even warn you about potential issues.
That's super helpful. It's like having a second set of eyes looking over your code to make sure you haven't missed anything crucial.
Precisely. Now, another common pitfall is calling use callback within a loop. Remember, hooks can only be called at the top level of your component. If you find yourself doing this, it's usually a sign that you should extract that logic into a separate component.
So instead of trying to cram all the logic into one giant component, we break things down into smaller, more manageable pieces.
Exactly. This not only makes your code more readable and maintainable, but also plays nicely with React's rendering lifecycle.
It's like organizing your workspace. Instead of having everything piled on one giant desk, you create dedicated spaces for different tasks. It keeps things tidy and helps you focus better.
That's a great analogy. Now let's zoom out a bit and consider the broader implications of these optimization techniques. The principles behind use callback and memoization extend far beyond just coding.
Oh, I love when we can connect these technical concepts to everyday life. It makes them feel so much more relatable and relevant.
What's fascinating here is that caching and optimization are fundamental concepts that apply to countless aspects of our lives. Think about how you organize your kitchen, how you plan your day, even how your brain stores memories. We're constantly seeking ways to be more efficient, to avoid repeating unnecessary work.
It's like having a mental cache for frequently accessed information. If I know the layout of my grocery store, I don't have to wander around aimlessly every time I need to buy milk. I can go directly to the dairy aisle.
Exactly. And just like in coding, there's a balance to strike. If we try to memorize or remember absolutely everything, we quickly become overwhelmed. The key is to identify the areas where caching will have the most significant impact and apply it strategically.
So it's not just about remembering things. It's about knowing what to remember and when to let go.
That's a profound insight, and it highlights the importance of understanding the trade-offs involved in any optimization strategy. In coding, as in life, there's no one-size-fits-all solution. The most effective approach is often the one that's tailored to the specific context.
This deep dive has definitely given me a new appreciation for the subtle complexities of React and the power of seemingly small optimizations. Who knew that remembering a function could have such a profound impact on performance?
It's a testament to the ingenuity of the React team and the ever-evolving nature of software development. As we strive to build increasingly complex and interactive applications, finding ways to optimize performance becomes paramount. And understanding these principles at a deeper level can make us not only better coders, but also more efficient thinkers in all areas of our lives.
This has been so insightful. It's amazing how these principles can be applied not just to coding, but to everyday life. So as we wrap up our deep dive into the world of use callback, what are some key takeaways our listeners should walk away with?
Well, first and foremost, remember that use callback is a powerful tool for optimizing performance in React applications. But it's not a silver bullet. Use it judiciously and focus on understanding the core principles of caching and optimization.
And don't be afraid to experiment. Try using use callback in your projects and see how it impacts performance. You might be surprised at the difference it can make. But also be mindful of the potential pitfalls, especially when it comes to dependency arrays.
Absolutely. Pay close attention to your dependency arrays and make sure they include all the necessary variables and functions that your cached function relies on.
I think it's also worth emphasizing that optimization isn't just about making things faster. It's also about making your code cleaner,
Yeah,
more maintainable, and easier to understand.
that's a great point. Sometimes the best optimization is simply writing better code in the first place.
Now, before we wrap up completely, I want to leave our listeners with a thought-provoking question. How can you apply the principles of caching and optimization to other areas of your life?
Where can you streamline your processes, eliminate unnecessary repetition,
Yeah.
and free up mental energy for more creative endeavors? It's an exciting challenge, and I encourage everyone to explore it further.
It's like we've uncovered this hidden layer of efficiency that exists everywhere once you start looking for it.
And that's the beauty of these deep dives. We gain a deeper understanding not just of the technical tools, but of the underlying principles that govern so much of our world.
So as we wrap up our exploration of useCallback, what's the one thing you hope our listeners will take away from this episode?
I think the most important takeaway is to remember that use callback, like many tools in our developer toolbox, is a means to an end, not a destination in itself. Understand the why behind it, when it's truly beneficial, and when it might be adding complexity without much gain.
And perhaps even more importantly, to consider how these principles of caching and optimization can be applied to other areas of life.
Absolutely. Where can you memoize tasks or information in your daily routine? What processes can you streamline? It's a fascinating thought experiment, and one that I believe can lead to greater productivity and creativity.
Well said. We've covered a lot of ground today, from the nitty-gritty of use callbacks, syntax, and dependencies, to the broader implications of caching and optimization. It's been a fantastic journey.
It has, and remember, this is just the beginning. Keep exploring, keep experimenting, and keep diving deep into the world of React and beyond.
That's a wrap on today's deep dive on useCallback. We hope you've enjoyed this exploration and have come away with some valuable insights. Until next time, happy coding and happy optimizing. It's like we've uncovered this hidden layer of efficiency that exists everywhere once you start looking for it.
Yeah, it's kind of like once you see it, you can't unsee it.
Exactly.
And that's the beauty of these deep dives. We gain a deeper understanding, not just of the technical tools, but of the underlying principles that govern so much of our world.
So as we wrap up our exploration of useCallback, what's the one thing you hope our listeners will take away from this episode?
I think the most important takeaway is to remember that use callback, like many tools in our developer toolbox, is a means to an end, not a destination in itself. Understand the why behind it, when it's truly beneficial, and when it might be adding complexity without much gain.
And perhaps even more importantly, to consider how these principles of caching and optimization can be applied to other areas of life.
Absolutely. Where can you memoize tasks or information in your daily routine? What processes can you streamline? It's a fascinating thought experiment, and one that I believe can lead to greater productivity and creativity.
Well said. We've covered a lot of ground today, from the nitty-gritty of use callback syntax and dependencies to the broader implications of caching and optimization. It's been a fantastic journey.
It has, and remember, this is just the beginning. Keep exploring, keep experimenting, and keep diving deep into the world of React and beyond.
That's a wrap on today's deep dive on use callback. We hope you've enjoyed this exploration and have come away with some valuable insights. Until next time, happy coding and happy optimizing.